Welcome, everyone. It is my honor today to introduce Dr. Jeanne Nijhowne. She is an archaeologist, and she wanted to be an archaeologist starting in grade school, she tells me. She has a bachelor's degree in anthropology from University of Washington, a PhD from Binghamton University. She's been an archaeologist in field at many different locations in Egypt, Iraq, Turkey, Syria, and Jordan on some sites that go back as far as the 8th millennium. Yep. And I had to ask, that's approximately 10,000 years ago. Yeah. She came to Boulder in 2006 and joined the Department of Physics as our graduate program assistant in 2007. So she has mentored through about 4 generations of graduate students through our program. So we're very pleased for that. She's also taught courses at CU in ancient Egypt for religious studies and Mesopotamia for anthropology. And so she got interested in this particular topic about 7 years ago. So I give you Jeanne Nijhowne, The Fascinating History of Numbers in Ancient Mesopotamia.
This was on. Thanks for coming, everybody. Numbers are so pervasive in our lives that we don't even think about them. I mean, why would you? Numbers just sort of are. And I will put myself in the same category. I've never really thought about numbers either until, as Paul said, about 7 or 8 years ago. And Paul was chair at the time, and he came to one of my lectures in ancient Mesopotamia on the origin of writing. And after class, we were chatting about it, and it was Paul who said, well, writing is cool, but what about numbers? So what do you know about that? And the honest answer was absolutely nothing. And that's, I started researching it, and it turned out to be much more fascinating and much more convoluted than I could have ever expected. And that was the origin of this particular lecture was Paul's challenge to me about what I knew about the origin of numbers. So before I get started, most of you in here are either physicists or astrophysicists or data people, and you're all about precision with numbers. And archaeology doesn't really have the luxury of precision. We don't really do that. Now, this is the best definition of archaeology that I've actually ever seen. It's the science of constructing the least improbable hypothesis out of a multiples of inexactitudes. It's just the way it is. So what I'm going to tell you today, this is my most probable hypothesis out of my multitude of inexactitudes for numbers. Okay, so to begin, I put this little chart together just to kind of put things in perspective for you. So the Paleolithic era means Old Stone Age, and it's at least, say, 2,500,000 years ago. So humans and their ancestors, all during this period, say for roughly 2 million years, all lived as hunter-gatherers, and that means in small mobile groups. They didn't leave a lot of evidence on the ground. Modern humans appeared here between 100 and 200,000, except again this exact time frame. So during this entire time, I said there was no settlements, no written history, just these small mobile groups. This little pink stripe here at the very, very end represents, as best I could, about 5,000 to 6,000 years when civilization, as we would identify it, as it exists. So again, this is how long we've had civilization in reference to how long we were hunter-gatherers. Now, from modern social cultural anthropologists who have studied language in these groups, again, we're talking about numbers, have found that for the most part, hunter-gatherers got by with words for 1, 2, and more than that. And if you think about it, in our everyday lives, not your work lives, but in our everyday lives, this is pretty much how we talk as well. We're not terribly exact, 1 and 2, and then, whatever, more than that. And our language actually reflects this. So we have a lot of words for 1. I actually looked up in the dictionary how many words there were for 1. There's 64 words that mean 1, and I'm not going to subject you to all of that, but there's single, solo, individual, lone, and you get the idea. So there's lots of different ways to say 1. And we also have quite a few ways to say 2. So we have double, pair, twin, couple, duos, and duets, all words that mean 2. Now, at this time, as much as we can tell, and this is a really important concept that is going to come in later, there was no abstract numbers that existed. In other words, the concept of quantity and object were melded together. So it would be 1 sheep, 1 rock, 1 tree. There was no concept of tree being separate from quantity. It was a single thing together. And the best way I can demonstrate this is with our collective nouns. So all these, we have hundreds, if not thousands, of collective nouns, and they all mean more than 2. So these are crowd, like you have a set of dishes, a bouquet of flowers, bunch of bananas, flock of birds, herd of buffalo, and a school of fish. So at some level, those collective nouns actually imply what's being counted because they're not interchangeable. So we move one over. You can't say a herd of fish, a school of flowers, or a bouquet of people. It makes no sense. So this is what I mean about quantity and object being melded together. So going back to our timeline, we have, say, 2 million years of hunter-gatherers doing their thing. And here, if you notice, I have 10,000 here in a different color. This is the beginning of the Neolithic revolution. Neolithic is simply New Stone Age, and it really was a revolution. And during that time, life completely changed. We'll talk about that in a second. And within about 6,000 or 7,000 years, writing appeared. Now, there's 6,000 or 7,000, seems like a fairly long time, but put against the backdrop of 2 million years prior, this was a very rapid transition. The Neolithic 10,000 was about the end of the last ice age, and the time where we're talking about is in the Fertile Crescent. So this is modern Iraq, modern Syria, Lebanon, and Israel in here. So it was all during this area that this transition took place. It didn't happen simultaneously, fits and starts, but for our purposes, there was a general shift from hunter-gatherers in this entire area of the Fertile Crescent. I will preempt one of your questions about why did this take place when it did? And the answer is we don't know. All the single explanations such as warfare, population explosion, climate change, you name it, it doesn't explain it. We really don't know why after 2 million years this rapid transition took place in this particular area. So here's, say, 10,000 or pre-9,000. Everybody's hunter-gatherers, and in this very short space of time, just a few thousand years, again against the grand time scheme of 2 million, these are tent rings, so this indicates a mobile settlement. We see a shift in habitation from round dwellings to rectangular or square dwellings, which means that they are permanent. There's plant and animal domestication and the invention of pottery. If you're a hunter-gatherer, you're not lugging around pottery, let me tell you. So this is, all of a sudden, people started settling down, permanent settlements, plant and animal domestication. And again, this took place over a few thousand years. And at the beginning of the 4th millennium, we have the rise of complex societies. And this is what we know as civilization. So this is urbanization on a large scale. I'll show you that in a minute. Social stratification. What social stratification means is that you are born into a position in your society. You didn't earn it by your own talents and so forth. So you're born into an upper class family, or you're born poor, middle class, or you're born into a profession. We have official religion, the beginning of metallurgy. I'm going to slip through this, but it'll become more apparent. This whole area was settled on a large scale, but only at the very end of the 4th millennium do we see the first true writing. So this entire 4th millennium right here is known as the Uruk period. So this is a map of Mesopotamia here. Mesopotamia literally means the land between the rivers. It's Greek. The southern part of the floodplain is known as Sumer. Here's a dividing line here. The northern part is Akkad, and together in the 2nd millennium it becomes Babylonia. What's important to note here is these are linguistic terms. These are not ethnic terms, meaning Sumer refers to a language as does Akkadian and Babylonian. These do not designate ethnic groups. They were probably always ethnically very mixed. Ethnicity is really difficult to define in modern times, let alone in the archaeological record. It's really, really difficult, and you're kind of stupid to even try. Sumerian is actually called a language isolate, which means it doesn't have any relation to a language, living or dead. We don't really know who these people were. Akkadian and then later on Babylonian are Semitic languages, which is related to actually modern Hebrew and modern Arabic. The entire 4th millennium was named after the type site of Uruk down here. So remember, this is always gone, this massive urbanization in the 4th millennium. There is no writing and there is no numbers. It's really phenomenal. So I put this scale on here for you. So the site itself is almost 2 miles long. You'll see here the outline of the city wall. And it covered over 1,100 acres. Population estimates are really difficult, but minimally population, 20,000 people, 20 to 40,000 people we're talking about living in this massive urban center. It was built around the ziggurat of Jeanne and the ziggurat of Anu. And here's some pictures of them right here. This is obviously the archaeological remains. A ziggurat is basically an artificial mountain. It's solid mud brick. These are not pyramids. These actually predate the pyramids by at least 1,000 years. But obviously it took massive amounts of labor, political organization, mathematical skills to design these things, to get the labor together to run these things. And Anu right here is the head of the pantheon. He was the head of the Mesopotamian pantheon, and Jeanne is one of the main goddesses. So here's a drawing of these 2 ziggurats. There was temples on top, so they built artificial mountains and put the temples on top. The other thing that's really amazing, especially when in this context of numbers, is this economy was a centralized economy run by the temples. So the texts tell us that the farmers and whoever was producing would bring their produce and their grain, their animals, what have you, into the temples, and then it would be redistributed back out in the form of rations. And we have rations lists, we know this. And again, they're running this without numbers. It's amazing. And obviously the farmers were producing more than they could eat because they had to feed the temple personnel, they had to feed the builders, and so on. This I wanted to show you just because it's cool. This is the famous stone cone mosaic beside Uruk. Here's a drawing of it. These were clay pillars, and they took stone cones and flattened the edge and then colored them, shoved them into the clay for patterns. These really look like textile patterns. But one thing I did not mention is that Mesopotamia seemed to be sort of a really kind of an unusual place to have a major civilization form because it had no metal, it had no wood, and it had no stone. It had dirt and water. And why this major civilization took root in Mesopotamia, is kind of pretty doggone amazing. So if we have stone here, by definition, that's imported. It was not local. During the 4th millennium also was the invention of cylinder seals. Again, this will come in a bit later. These are fairly, actually this is 2 centimeters. I did my dissertation on cylinder seals. I know about cylinder seals. 2 centimeters is actually a big one. A lot of them were much, much tinier, and they were carved in the round so they could be rolled out onto clay tablets. But again, look at the level of artistry of those things. This wasn't just, you know, somebody doing this in their spare time. These are just absolutely stunning works of art, and the first things to be looted in museums and looted off sites too. So we have Uruk, this major urban center down here during the entire 4th millennium. Well, then we're switching up to today, and in the 1970s, again, modern times, the Syrian government, there's no modern lines here, decided to build a dam right here, the Tabqa Dam on the big bend of the Euphrates. But they let the archaeologists in there to do some rescue archaeology on these couple of sites up here. And this was the French, the Germans, and actually the Americans were up there too. And lo and behold, they found bevel rim bowls. These are known as the paper cups or the styrofoam cups of the 4th millennium. They've been found by the thousands. They are absolutely indestructible, I said. And there is a theory, again, a hypothesis, that this might have been part of the ration system, not sure. But these sites up here, Jebel Aruda and Habuba Kabira South, look like they were literally transplanted up onto the big bend of the Euphrates. Well, look at the location. There's really no other way to interpret these sites other than these were trading colonies in the 4th millennium BC, because they were trading with, this is Turkey, and this is the land of the Silver Mountains, and Lebanon is the land of the cedar forest. They were wood, and of course the Big Bend is the perfect place. They'd haul it overland, plunk it in the river, and go down the river down to Uruk. And here you can just see the tip of Cyprus. And I've actually been in Syria and you can stand on the coast of Syria and see Cyprus, and I know because I've done it. So they were trading products of the Mediterranean as well, grapes, wine, and things coming in from the Mediterranean. So this was a huge, sophisticated society, all functioning with no writing and no numbers. Before I leave Uruk, I wanted to tell you about this other part. This was the marshes, and this was a huge natural wetland of the Tigris and the Euphrates down here. The Persian Gulf at this time was a bit higher, and here from 4th millennium Uruk cylinder seals, this was a depiction of the way of life in the marshes. These were reed huts. You can see the cattle. Here's a silver boat that was found in a 3rd millennium grave, but this is superimposed on a modern picture, and you can just see how closely it matches. You have the cattle here, the reed huts here, and look at how similar these boats are. So this is a way of life that really hadn't changed in thousands of years. Here's a couple of pictures of the modern reed huts, and here's some pictures of the reed huts on the cylinder seals from the 4th millennium. This was from the 1970s. There's actually a cow swimming back in here. But this, you could be looking at the 4th millennium BC in that photograph, which I think is totally amazing. I'm taking speaker's choice to diverge a little bit and bring in some modern commentary, if you will. This is one of the places I'm going to do that. Saddam Hussein decided that he did not like the Marsh Arabs because they didn't practice the kind of Muslim religion that he had. They were a different sect. He diverted the water and ruined the marshes. It's very, very tragic. There's a little bit left, but he really wrecked a major wetland. Okay, so this is the way I learned it, that Uruk was this huge center functioning without writing, without numbers, and then writing just kind of appeared out of nowhere at the end of the 4th millennium. Enter Denise Schment-Besserat, and I don't know if I'm saying her name right. She is a French archaeologist working in Texas. She was actually building on some of the work done by her advisors. And she got interested in the non-pottery uses of clay. So what she did is she went to museums all around the world and was looking at clay artifacts, but that was not pottery. And she kept running into these little clay, eventually she called them token. I did some show and tell for you. So I made some of my own Play-Doh and made some little, see they're very tiny, little 1 centimeter things. And in museum displays, collections, they were looked at as toys, they were game pieces, they were beads, they were unknown. Nobody really knew what they were, except that there was a fair amount of them. And these go back to, again, 8,000 to 3,500 in that transitional period of the villages. She came to understand after decades worth of work that they were part of an early accounting system. So once people settled down in villages and started to trade animals and grain and so forth, they had to have a way of keeping track of their stuff. And so, as I said, they didn't have very many natural resources, so they could bend down, pick up clay, a little bit of water, and bingo, you've got a clay token. And again, this was so each shape meant a different commodity. So like the flat disc, and I think there's one with a cross, and that meant a sheep. And I said there was been some pushback on there, but there's definitely some artifacts that have shown unequivocally that that's exactly what a lot of these tokens actually were. This is from the 4th millennium. Here's a clay ball. This is a seal impression on there. So there's 16 tokens inside this ball. And I said that's the cylinder seal impression. Cylinder seals have unique designs. No two are alike because what they do is they represent an individual. So each one had to be different. So this was a marker of who actually owned that particular clay ball and the tokens inside. So plain tokens, which are the ones with no decoration, these little ones that I made, are found all over the Mesopotamia here. You find them on sites all the way over into a modern Iran, Turkey, and down here and in Israel. They were, Leo, did you have a question?
Yeah, I was wondering, how do they deal with anybody could just make a little...
Yeah. Well, since we have no writing, we don't know that. So, but I think that's, we don't know. But they were all, whether each shape meant the same all over that whole area, again, we're not sure about that. Here is a rook in this map. Susa is the main site over in modern Iran. And again, I put this up just to show you that the token system was very, very widespread. So these are plain tokens from Iraq, and here's our ones from Syria. And I put in, here's the most of them are just a centimeter. I said they're actually just pretty small, and in various shapes for the various commodities. So at the beginning of permanent settlement, we have plain tokens came in at about the same time, and they lasted all the way through this transitional period from village life into major urbanization. So with urbanization, I mean, you can obviously see the problem with tokens, right? I mean, how much information can this actually convey? And the answer is very, very little. So as we get into this major urban center of Uruk, they had to find a way to convey more information on their tokens. So what they started doing is not only they had just basic shapes, there's only so much you can do, but then they started making lines and puncture marks and striations and little holes just to differentiate, because, okay, you have a sheep, but you can have an old sheep, a young sheep, a female sheep, a pregnant sheep, a lamb, all different varieties. Here's another illustration of a basic token shape with lots of different variations, probably to convey different kinds of information. And I said a lot of these, we just really don't know what they meant. But the idea was they were trying to find ways to convey, to encode more information for their transactions. This here, I said I circled because these are more definitive, that you can really tell what they are. There's 4 jars here of different shapes, probably again indicating different kinds of commodities. These tokens, she had felt that she had a more definitive feel for what they actually were. So here's a garment. This little statue here, this is quintessential Sumerian. Sumerian statues are always bald. Their hands are like this with this flounced skirt made of probably of wool because they did have sheep. So that would be a garment, an ingot of metal. Here's the sheep token, honeycombs, that might be a loaf of bread, and so forth. So sites with complex tokens, again, are found all over Mesopotamia, and notice up here in the Big Bend, this is a crappy map, but this was the Big Bend of the Euphrates, those sites I was telling you about. And we only have one site with only complex tokens. That we call an artifact of excavation, which means there's no plain tokens because the excavators threw them away because they were boring and kept the pretty ones because they were cool. So that's kind of what that's all about. Well, again, the problem with tokens is, you can tell is how do you keep them together? I mean, these were very practical considerations. So this is where clay envelopes were invented. And this is an original clay envelope with some of the tokens that were inside and some of the cylinder seals. Here somebody just, kind of made one. There's only a couple. I think I only found 3 clay balls with tokens actually inside that were actually intact. But what this shows us is that, again, definitively, there was a token system, and these balls were being used as part of an accounting system. This is what was known as the Rosetta Stone of the token system. This was actually from the 2nd millennium, but there was 48 counters in here and of tokens, and the cuneiform, which was in existence by this time, actually spelled out what the tokens were. So again, definitively, this is what this system was. And here's just another one from the 4th millennium, and here they have 4 days, 4 metals of measure, and this was payment for labor. Another way they could find things to hold them together was they put holes in them, put them on a string, put clay, and then put the cylinder seal over. Here's another one from Syria. But again, not terribly efficient. Eventually, towards the end of the 4th millennium, somebody got the bright idea of actually impressing the tokens into the outside of the balls. So here's the flat tokens that were impressed here. These 3 cone things were pressed in like that, and here's the big one, right? So then when you put the tokens inside, you sealed up your ball, then you knew what was inside based on what was on the outside. Well, shortly then, of course, they figured out, well, if we're doing that, why do we need the tokens anyway? We can just draw the tokens on the tablet and then put some sort of a designation for quantity here outside. In this here, about 3300, 3200, was a really important turning point in the origin of writing and the origin of numbers, because this was the point where the quantity and the object got split apart, is when they started forming tablets. They weren't going to draw 20 tokens. They were going to put down one drawing of the token with some sort of numerical symbol to tell you, the user, what this was. And again, this was just made with a stylus clay and reeds which grew in the rivers and in the canals. And so this is the first early example of writing and like in the number system. So before I leave tokens altogether, Denise Schmidt-Bezeret came up. These were the tokens. This is what they meant in here in English, so a sheep, cattle, dog, and so forth. These were the pictographs that were drawn on the clay tablets. And then later on in the 2nd millennium, this was the cuneiform equivalent. So it was really, writing all really came about because of the drawing of tokens on the tablets, and then eventually the splitting off, removing that idea of quantity from object, and that allowed writing to take off because those words and syllables no longer contained the idea of quantity. So this was a really important division for both numbers and writing. This was said a proto-cuneiform tablet. Again, we're getting at the end of the 4th millennium here, but this is, you can see the picture of the token drawn here, and that's the picture of the ration bowl. I showed you the bevel rim bowl. See, that was the symbol for the ration bowl on the tablet. So here we have the pictographic script, the takeoff of writing. And for us now, we're leaving writing behind and moving on to the quantity symbols. So they still hadn't developed numbers. And I'll get to this in a second, but they had multiple metrological systems in use for a millennium. And this is multiple ways of counting. And this is where it gets really convoluted, and I thought it's really, really interesting. These are archaic quantity symbols. You'll notice that this is a base 60. The gods in the Mesopotamian pantheon, gods and goddesses, each had a sacred number. The head of the Mesopotamian pantheon, Anu, who I showed you the ziggurat, his sacred number was 60. Again, why 60? Answer, we don't know. That's the way it was. That was the way it was before the dawn of their time, before the dawn of history. Anu was 60. Numbers also had a sacred element, a sacred quality to them in Mesopotamia, which, to be honest, we really don't understand what that was, but there was a sacred aspect to numbers as well. Mesopotamia has always stuck with a base 60, but these things, these symbols, are not numbers, and this is where it gets really, really complicated. So these are just some pictures of a clay tablet with some of these symbols on them. And I wanted to give you an idea about what the actual size of these things. So you can see they split them off into sections so you could tell what the token, what the picture was, and then here's the number symbol. So this had, again, end of the 4th millennium, grain, bread, beer, so it had 4 different commodities. This tablet is only 2¼ inches by a little less than 2. So this is where my Play-Doh came in. I did show and tell for you. This is an actual size of this thing. That tablet is this size exactly, as much as I could make it. And then to put it into all these different registers, plus draw the pictures. I drew the registers and I gave up on the pictures and the quantity symbols. It was too little. But these were very, very small. And yeah, I can't imagine how they did it. So we're moving into the metrological system. So this tablet here, this is a drawing of it. You'll notice these little half wedges here. There's 11 of them. This is where they were added up. So in this particular system, each one of these half wedges once you got to 6, you got a circle, and then there was 5 left over, and that equaled 11. So this was barley rations. So they were using the system S here. So this was capacity measures of barley, and that's what I just showed you right there. However, if you're counting discrete objects, you use a sexagemus, I can't say it, I tried, system S, and you notice these are the same symbols, but here they go up by a factor of 6, here they go up by a factor of 10. These two symbols are the same, they go up by the same factor. This symbol is in a different order, and again, so out of those 60 symbols, you had to know which symbols to use in which order for what you were actually counting. There was actually 13 systems that have been identified so far. So, and this is where you are so grateful that you're not trying to use this. And this was, I said, in use for 1,000 years, from the end of the 4th millennium to all the way through the 3rd millennium. So here's our N1 system. So discrete object, here's a 1. If you were doing a cheese product in the ration system, 1. Here's an area measure 1. However, if you were counting a dead animal, then you would use that symbol as a 1. I kind of like that one. And again, you had to know which certain objects went with this sexagesimal system S prime. Here's another ration system here. And here are time and calendar units, which uses this system plus another symbol to equal a day. I'm just giving you some examples here of how complicated this is. So here's the N1 symbol again. And down here it appears, but it appears down the way for whatever this counting system was for, and then in conjunction with another symbol for time. These two symbols are the same, N45 and N50. Here's N50. So here, in these two systems, they're in reverse order, and they go up by different magnitudes. Here it's, I can't read it very well, 10 and 6. So again, they're using the same symbols, but in depending upon the system, which order they go and what amount of magnitude they're from. So a dot here could be 10 clay pots of butter oil, a measure of grain, here a field of about 6 hectares, and here, this one is at the end of this system, and then here, this was 10 days and 10 months. So this dot seemed to have some sort of inherent 10 about it. These seem to be paired, the N1 and the N10, or is it N14 system, here in this system. But in this system, there's another symbol in between here. So scribes had to be trained, as you can imagine, for years. There's some evidence that they ran in families, so imagine fathers were start teaching sons early on. And in some places, they actually had female scribes as well. Here's the last 6 of the systems. And these really contained were grains. We have barley, and this is measures of germinated barley and barley groats. And you can see these are basically the same symbols, and then the little dashes and dots and marks refer to which kind of barley and which kind of grain you were referring to. But at least they had the decency to use the same symbols in the same order with the same magnitude, so that was something, right? And over here, these other two systems seem to apply to milk products and dairy products. But before, this is the end of this, but before we get really too smug about these crazy Mesopotamians sticking to this incredibly difficult system for 1,000 years, may I remind you that we Americans are sticking to our tablespoons and our teaspoons, and now you tell me what the rationale for that is. I mean, I have no idea. So this is why I love Mesopotamia, is because they're so identifiable. We kind of get them. It's like, always done it this way, we're sticking with it, we don't care how hard it is, we're going with it. So there we go. My last example in this is a really fun tablet. This one is one of the more famous tablets, again, around 3000, sort of the end of the Uruk period. Again, and this is the same tablet, just in, and this is production for calculations of basic ingredients for production of different types of beer. But this is how educated these scribes had to be, because here's one quantity, and I can't read it from way down here, but I think this was the bisexagesimal system. No, that's the sexagesimal system. This is a sexagesimal system. This was that's the ration bowl system. This was a calculated quantity. This was a pictograph, which had an inherent value. And what I can say here is, you think of like a bushel basket, which is an inherent quality. It was something like that. And our ever popular scribal error on the tablets. So when they put this on the tablet, and again, these things are tiny, they had to know all these different systems and get it right, except sometimes that they didn't. Yeah?
I'm trying to say, is this a currency, or is this the way a person can keep track of what they own?
This is accounting, yeah. This was probably...
keep track of their supply.
Yeah, remember they had this huge redistributive system where people are bringing in. So these are all accounting. This is all an accounting system. All run by the priests. Who owned what, outgoing, and yeah, this was keeping track of commodities. Yeah.
Is there a concept of very certain amount of people for the scribes and the it's like you kind of think about the chart and keeping track and making sure it's all regulated.
There probably was, and again, but a lot of these tablets were looted, and the excavators, this was stuff, especially work was done in the 1920s and 1930s by German excavators, and they just had, it was in the early stages of archaeology, and they didn't really keep track of stuff. They wanted the tablets, and wasn't so important about where they came from, and so reconstructing a lot of this stuff is just really difficult. Yeah.
The tablets are a right ones. But trading is a dynamic business, right? You're selling stuff, buying stuff, so you have to keep making more tablets.
Mm-hmm.
How do you validate the old ones? How do you say this tablet doesn't count anymore, it's a replacement for the food?
They might have broken them.
I mean, there's no way it says you don't track somehow. It says this tablet's updated.
You can't hit delete. I don't know. This is the province of epigraphers or philologists, epigraphers. I'm happy to say I'm an archaeologist. I am not an epigrapher. Trying to deal with all this language is just like, no, thank you. We can talk cylinder seals in the second millennium. That's my thing. Okay. So moving on here quickly, because I'm probably running out of time, as I'm always afraid. So all these systems were going on in the third millennium, and I just had this one arithmetic tablet from Pharaoh, which is here in the central floodplain. So if you were doing arithmetic in the middle of the third millennium BC, that's what you would have gotten for your homework or something, which I think is maybe a bit daunting. I need to switch gears here, and again, I'm kind of running out of time, so I'm going to kind of run through this quickly. I need to give you the historical background, the cultural context, otherwise the rest of these changes aren't going to make any sense. In the middle of the third millennium, we have the first real empire formed by Sargon the Great and his grandson, Naram-Sin. It was really short-lived, only about 75 years. Akkad is here. To be honest, the site of Akkad, his capital, has never been found. It's probably underneath the groundwater. Don't know where it is. It's about there. He conquered this area, and these brown lines here he made alliances here. You can see that. But it was the first real empire, maybe ever, in the world, and certainly the first one in Mesopotamia. One thing I wanted to point out here is this difference between Mesopotamia and Elam, which is Iran. That border is basically the current Iraq and Iran border. That has been in existence since prehistory. These two areas have never gotten along. And in fact, the first tablet we have of a war is between a king of basically Iraq and the king of Elam. It just goes thousands of years back. So one of the alliances he made, this is our first evidence of a diplomatic marriage. Naram-Sin, that was the grandson. His daughter, her cylinder seal was found at Urkesh. Urkesh is very dear to my heart. That's where I was working in 2009 and 2010 when I was on leave from the physics department. I was going up there in 2011 before the Arab Spring. This was a Hurrian site. Again, a really unknown group. I'm sure most of you, probably none of you, have ever heard of them. An amazing site, but he sent his daughter there to make a diplomatic marriage, as proved by her cylinder seal. He also conquered, both of them conquered Ebla. Ebla was the center of this huge trading center in Syria in the third millennium. This is the site of Ebla. You can see that the walls are still intact. This was the citadel. And of course, the Italians dug here for about 14 years before finding the tablets. I was working, the first time I worked in Syria, I was working about 20 minutes from there. So we popped by after work one night. And this, actually, I took this photograph. That's all of us standing on the edge of the big pit in Ebla. And what I wanted to show you here is there's two lines of destruction, one here and one here, which kind of shows, backs up both Sargon and Naram-Sin's claim of having destroyed Ebla, because there's kind of the proof of it right there. That dynasty fell apart pretty quickly. The Gutian interlude was just nomads that came down from the hills, took advantage of the chaos. We have anarchy. And this was from the Sumerian king list, which I love, like who was king, who was not king. Hirgigi was king, Nanam was king, Emi was king, Alula was king. Those 4 kings ruled in 3 years. That's a sign of serious political instability, okay? Not good. So then the last one I'm going to tell you is about the 3rd dynasty of Ur 3, the last 100 years of the 3rd millennium. And Shogi here for our talking about numbers is really important because this was the last great Sumerian dynasty. Shogi reconquered basically everything that the Akkadian dynasty had done, but it was during his reign that there was the development of the sexagesimal place value notation. Either Shogi or more likely his scribes finally got fed up with all those metrological systems that I was telling you about. They were gone, and finally we get real numbers in Mesopotamia. Still base 60, but this is the cuneiform version, and all those other weird systems that lasted for 1,000 years were finally out the window. They really had it. They were trying to run an empire. They didn't have time to deal with it. So out they went. Now, this is my second kind of waltzing into modern commentary. So this, another empire that didn't last very long. They were being pressed by the Amorites off the desert. The Gudians were coming down. What happens when people feel threatened, when people are invading their territory? What do people do? Who said that? Build a wall. Of course you do. You build a wall. So you've heard of Hadrian's Wall. You've heard of the Great Wall of China. I will bet you have not heard, unless you've heard my talk before, the Red Snake Wall of Gorgon. This was actually only discovered in the late 1990s. Once they were doing aerial photograph, you can see a picture of it right here. Here's one of the forts about every kilometer. It was second in length only to the Great Wall of China, about 121 miles long. But before that, we had the walls of the 3rd dynasty of Ur. Again, we know these from the text. We don't have the walls themselves, but they talked about the wall of the land built in 2070 BC. And then about 30, 40 years later, they talk about the Amorite wall. But when they described the location, it was clearly closer to the center of Ur. Moral of the story, we've tried this, been there, done that, didn't work, not gonna work, don't waste your time. We could learn from history if we wanted to, except that we don't. So when they fell, we have, again, another period of chaos called the Isin-Larsa period. Isin and Larsa were the 2 big city-states that kind of came out of the fighting. They were fighting over Nippur. Nippur was the holy city. Think of it like Jerusalem. That city god, Enlil, had taken over the pantheon. Whoever controlled Nippur got to proclaim themselves king of Mesopotamia. So while Isin and Larsa were busy fighting over Nippur, and again, the texts are fabulous here in this time period, that changed hands, I think, 17 times in the space of about 150 years. So the southern floodplain was busy fighting over Nippur. At the same time, the Amorite tribes were settling in north of the floodplain where they were being left alone. At this time, and one of those places was Babylon. And you probably all have heard of Babylon. At that time, it was just a little provincial town, one of hundreds. I will use my own term. It was like Longmont or Lafayette or Louisville. I mean, it was there, but no big deal. Well, the kings of, I didn't want to offend anybody, but they formed the core of the 1st dynasty of Babylon. And about the time Rim-Sin of Larsa finally defeated Larsa, we have Hammurabi becomes the king of Babylon. And if you've heard of any king of the old Babylonian dynasty, it's Hammurabi. This is the Hammurabi of the Code of Hammurabi, eye for an eye, tooth for a tooth thing. And after he'd been in power for almost 30 years, he went on the offensive against Larsa and again formed the old Babylonian Empire. So he conquered Larsa, then he destroyed Mari and created the 1st dynasty of Babylon. Again, why is this important? The Babylonians, I did my dissertation on Old Babylonian. They were the most fabulous bureaucrats ever. I love them. They dated all their tablets down to the day, month, year of king's reign. They put, we have fabulous data from them. And this is the main source of information for Mesopotamian mathematics, really come from the Old Babylonian period. So Babylon itself, the levels dating to Old Babylonian are underwater. We don't have anything there. I've actually been to Babylon a couple times, and all you get is first millennium levels. So the second millennium levels are underwater, unfortunately. Most of the information we have is from Sippar, which was in their orbit, and actually from Larsa. So now I'm just going to be showing you the state of Babylonian mathematics. People have a tendency to think beginning of math. What do you think? Greek? No. And I give a nod to Egypt. I really don't know a lot about Egypt, but obviously if they're building pyramids, they know their math as well. But here's just a table of reciprocals. This tablet is from Sippar. I said Old Babylonian homework about squares and so forth, but obviously you had to know cuneiform to do this. Then they know their geometry because one thing that Hammurabi did, which kings have done since, that is just not a good policy. After he conquered this empire, he had to reward his soldiers. Well, what do? He doesn't have any money, so he gives them land. Well, unfortunately, people had already been living on that land, so he kicked off the people who had been living on these lands for generations and gave it to his soldiers who didn't know what to do with it. And there was endless, and we have the tablets, just endless fights about who owned what land. Well, this is a site of Mashcan. Again, I worked on this site for a little while, and it looks like that. So when they were trying to define land and land boundaries, they had nothing to work with. So because the canals and the rivers shifted around, there was no trees, there was no mountains, there was nothing. So they had to map out plots of land on this kind of barren kind of landscape. That used to be an Old Babylonian city. So this was all, the rest of the stuff is really all about geometry. So here we have finding the chords of circles. Here we have, again, just textile patterns, kind of running through this quickly. It's clear from the tablets, this is from the Yale Babylonian collection, that they used 3 as estimate for pi, so for the area of the circle. And I put all this down, and again, it's all in base 60, so it's a little tough to deal with, but there we are. And that's, when you learn the cuneiform, it's really not that hard to figure it out. Here's another Old Babylonian geometry tablets of squares and areas, and here's the subdivisions here. And these were more math exercises that they had. So here's finding the areas of the triangles, finding the areas of irregular shaped land. And this tablet came up to light fairly recently. This was found actually in Turkey, because there's been a lot of speculation about whether the Babylonians knew about the right triangles. What am I thinking of? Pythagorean theorem, thank you. And this author came to the conclusion that they based their right triangles on rectangles, not circles. So this was definitely more sophisticated. And this leads us to one of the most famous tablets of all, Plimpton 322. I know you're just thrilled. But this was from Larsa. And this tablet is known because this was known as the Pythagorean tablet. Again, 1800 during, and these tablets are read actually from right to left. So, and I put this down here. So here's the rows, and I just put a couple of them. Here's the widths spelled out, the diagonals, and the formula, and they refer to these particular right triangles. So they definitely had a knowledge of right triangles, even if they based them on rectangles rather than circles. And the other thing they had, and this is a Yale, is this a Yale tablet? Yeah. And these are the numbers in cuneiform, so I kind of highlighted those for you, top and bottom. And it shows that they also kind of had a good approximation of the square root of 2. So they were sophisticated in their use of geometry and math. So the last thing I want to tell you about, and I'll have a couple of minutes for questions, and this is for the astronomers, is the Venus tablets of Ammisaduqa. Ammisaduqa was the second to last king of the first dynasty of Babylon. And he's famous for this one particular, it's called the Venus tablet, because these are actually observations of the phases of the planet Venus. Well, chronology and where the Babylonian period fits compared to our own time is always a challenge. People are always fighting about, with their high chronology, what the actual dates are compared to our calendar. Well, during the pandemic, so just a couple years ago, there was a retired mathematician from Oxford, England, that had time on his hands, so started running formulas and regressions and looking at when Venus would be in what phases in Mesopotamia during what years. And based on all that, which I won't even begin to try to explain to you because I don't understand it, is that he basically confirmed that what has always been considered the traditional chronology for Old Babylonian period is the most likely one, positive. So that was a real plus. So after the end, after Babylon fell, little is known about the development of mathematics for the next 1,000 years. The next 1,000 years is kind of a black hole. So to end, if you've ever wondered why we have 360 degrees in a circle, 60 seconds, 60 minutes, you can probably thank the Sumerians. Some people have argued that this isn't the case, but I'm a Mesopotamian person, so that's my story, and I'm sticking to it. Thank you. Do you do questions?
Comment. So the scribes had to have amazing nearsightedness in order to be able to do what they did.
Yeah.
And nearsightedness is a genetic trait, so it would follow in a family to some extent.
Oh, okay.
It could be the case that a scribe's family had the advantage of being highly nearsighted, which makes them useless for many tasks.
And also doing the cylinder sills, you had to have been able to see really, really close to do that kind of work. So, yeah. Okay, so
What was the role of the
cylinder seals? It was because they could be rolled out in a continuous line because they made a continuous picture when they were rolled out on a clay tablet. So it didn't really matter what size the tablet was. They could just roll it out. And that denoted ownership because I said each one was individual, singular. Yeah.
So my question goes back to the complex tokens. I was wondering if there was, if people were able to see distinction between, I guess, the advent of this standardized number system and, or I guess before the standard number system, there was a bunch of these different systems, but the start of those number systems and the standardization of those complex tokens across the whole region.
We don't know whether they were standardized across the region.
Yeah.
And I said there's a lot, some people even push back that they were part of the accounting system. I think that there's no question that they were part of the accounting system, but some of these might have actually been beads or toys or game pieces. And a lot of the stuff was just looted, and so the excavation, a lot of these tokens, especially from Uruk, actually did come from the temple area, which again lends credence to the fact they were part of an accounting system because they were running that whole ration system using tokens. Chuck.
When they're found, do they tend to just be in a pile, or are they found in some kind of order? Right? Is this like razor blades that people threw into the back of the medicine cabinet, or do they go into the garbage can that was in the temple, or are they like in a line?
They probably would have been together. I actually haven't looked at the excavation reports, but if they even actually, and I said, especially Uruk was excavated for years back in the 20s and 30s by the Germans, and whether that the excavators even, there's actually some levels with tokens, some without, which means some people kept them and some didn't. My guess is there was no record of they just didn't realize how important where things were found. It wasn't recorded. Eric.
So your timeline showed bureaucracy appearing several hundred years before, right?
Yeah, hundreds of years before.
Kind of a, damning indictment of the species. How do we know? How do we know there was bureaucracy without writing?
Because of the ration system and the temples, and a lot of this was, my guess, again, I'm a second millennium person, not a third millennium person, or a fourth millennium, so I will, again, a caveat, but a lot of this was being projected backwards because the later tablets was talking about the ration system, the ration bowls, and the tablets. Mesopotamian was really all about accounting. They were really into bureaucracy. I know the old Babylonians were. So I think what they did